This is going to be Oscar Minzer and Kathleen Lowry. Using public cycling data to recommend future bike infrastructure.
Thanks for sticking around, guys. Our presentation is pretty straightforward, so it shouldn't take too long. Okay. So we're both seniors at UNC Chapel Hill. We did this project last year as part of one of our classes. Take this off. Nope. Yes, the class was GIS programming, basically. So I'm Oscar. I'm studying environmental and computer sciences.
I'm Kathleen Lowry. I'm studying environmental science and GIS as a minor.
Cool. So we're going to go over basically using public cycling data to recommend bike infrastructure. Right. So our problem we were looking at was vehicle bike crashes. So this is an issue in pretty much every city in the United States. Anywhere there's cars and bikes sharing roads, you're going to have this problem, unfortunately. What's even worse, it's trending towards worse in the last about decade. And North Carolina specifically has been in the top 20, top 15, top 10 worst states for deaths of cyclists because of this problem. So naturally, the answer is bike-specific infrastructure, protected bike lanes, things like that. But obviously, cities don't have unlimited resources to cover their entire every road, and so there's choices to be made about where these go. So sort of one way to make that decision is to look sort of retroactively where crashes are happening and sort of put lanes there. But more ideally, you'd want to take a preventative approach. And so look at where people are actually riding their bikes, put infrastructure there so there aren't crashes to begin with. So to do that, not a super easy thing to do. You either have someone on the roads counting bikes, something ridiculous, or cameras. You could do a study with GPS trackers and get a sample of people for a period of time. All those things are expensive. We didn't do that, but what we did is, since people are already posting data like that every day pretty much, so like wearable exercise technology is blowing up pretty much. You have like Fitbits and Garmin's, iPhones, stuff like that, and a ton of people are using them to track their exercise. So if any of you are like a serious runner or cyclist like I am, you've heard of Garmin or Strava or stuff like that. And so you record your workout. It says where you go, how fast you're going, things like that. And it drops latitude, longitude points every second or so during your ride. So there are dozens of these posted every single day just in our tiny Chapel Hill zip code. So it's a widely used service. And it's also global. So it's a great resource for free data if you're doing similar projects. So we started with like 100 of these files we downloaded, and try to answer the question of where people in our city using bikes pretty much. I should also say this map is Chapel Hill. This is just north of our UNC campus. And these are all crashes that have happened over a period of several years, but still. So just to illustrate, it's a really serious problem.
So like Oscar said, we use these GPX points. So this is just a model builder of the overview of the method we use. We started off with these GPX points, converted them in ArcGIS to a point feature class, did a bunch of process, and we resulted in a heat map that showed a line density of the frequency of bicycle traffic around Chapel Hill. So to go through our method, again, we first started with these GPX points. We converted them to a feature class. We then connected all of those points into a line to show the bicyclist path. And we created a buffer around that to see where the path of the bicycle was riding intersected with the streets around Chapel Hill to see which street they were actually riding on. Our next step was to use that buffer to select those streets. And so that's what you see in red right here on the right. And so we selected all of the streets around Chapel Hill that are mostly being used. And for each GPX data set that we got, we had a selected street shapefile. So we ended up with over 100 of these shapefiles of just single streets. And so our next step was to take all of those streets and merge them all together into one shapefile. And so that's what you see on the left. And then we simply just used the line density tool, which was a lot easier than we thought it was going to be to begin with. and resulted in this map on the right. And this shows the frequency of bicycle traffic around Chapel Hill according to these GPX data points that we got offline.
Yeah. And then along the way, just to throw in a few of the details, like for this step, naturally, if you just throw a buffer around a line, you're not just going to select the street you want. You're going to select all the streets around it and have like a T-shaped thing at intersections and stuff like that. So we had to do a little bit more processing to make sure we were only getting a single street at a time, which is more just like troubleshooting. And then again, I just wanted to emphasize that the blue on the left is not just like a line we've drawn from these files. It's actually selected pieces of those streets. And so all the data from Chapel Hill, like road type, when it was built, speed limits, things like that, are all built into our data set and can help inform where the lanes go. So after we had our model built and working for one or two manual files at a time, naturally wanted to run this with the hundreds of files available online for free. So this was taking us like 10, 15 minutes like each to do by hand running this whole process. So we wanted obviously to use Python. So it's pretty simple script. We just exported our model builder into Python and then put a giant like for loop around it. And then obviously when you do that, everything breaks. And so we had to go through every single sort of process and fix those and define, outputs and things like that. But it does work. And so you just give it a folder with as many files as you want from Garmin or Strava, and it'll run through all of them and build an awesome heat map, which is on the right there.
So this is our resulting map. You can see over here, UNC campus is off to the right. So if you're familiar with the area, that's Franklin Street up there where you see a lot of the red stars. So like Oscar said, we use the for loop in Python to loop through over 100 GPX data sets that we got offline. So it proved to be a really efficient and effective process to go through a large amount of data and result in a density map of traffic around Chapel Hill with bicyclists. And as you can see, there's pretty heavy traffic along Franklin Street that bicyclists are using. There are currently no bike paths on that street. And so just for a visual effect, we also mapped bicycle vehicle crashes. And just to note, these are only reported bicycle crashes, so only when an ambulance had to be called to the site of the crash. Just from knowing people who also bicycle around Chapel Hill, there are several other cases of crashes where an ambulance is not called. So it is a big issue around there. So you can use from this map like a planning process of where future bike lanes should be implemented around Chapel Hill.
So like we said, this was done in a semester for a class. There's a ton of stuff we wanted to do with it. One of them was make this, use Esri's ArcMap Online feature set to upload the Python and make it so anyone could just plug in their zip code and it would automatically use, Garmin's API, grab the 500 most bicycle activities, and then produce this. We think that'd be awesome for, local city government, citizen groups are interested in what the stats are in their area, where bike lanes could go, things like that. And also, as we were saying, since Chapel Hill has, or most cities have so much data about their roads already, we could do a lot more advanced output. And so if you wanted to know like which, what the cost might be depending on the type of road, or if you had a budget in mind, maybe what are the most important segments to do first, things like that. And then more long-term, sort of out of our league with Python would be like a simple, AI-based, if it's not feasible for a bike lane to go there, how can you reroute most intelligently around an area? So it's like automated urban planning type stuff. So there's a lot I think we could continue with this project.
Just to note one more disclaimer, I mentioned this about the bike crashes, so these are only where ambulances are called. Another thing that we were thinking about is this is only where people who are exercising to use bikes are uploading their data. So again, this isn't a perfect model because there are a lot more of just commuters and they don't necessarily track their information the way these exercise bicyclists are using. So that's just another disclaimer about our data set that we acknowledged throughout our project.
That was the city of Chapel Hill, just .gov, yeah.
Bicycle crashes, I believe they're from
2011 to 13, I
Yeah.
think. Yeah, so that's too recent. Anything else? Yeah. Yeah, so we had trouble. Chapel Hill had like an existing greenway system like file. We couldn't get it to talk to make friends with ours pretty much. But yeah, there are a ton of streets already with that. So it's a good idea. So we did not look at time of day, but that's another thing that is included in Garmin's data, which is awesome and can be used. It also says like how fast the cyclists are going, and yeah, it's another good thing.
Yeah, I was going to mention the date and time aspect of the data as well. It seems like you can really use that information to assess the effectiveness of any infrastructure that is implemented. I live in Durham, and near me there's a 5-lane road, but two travel lanes in the middle, suicide lanes, if I can call them, Pennsylvania, making a left-hand turn across the lane. And then on a road diet to 3 lanes with 2 bicycle lanes on either side. And I'd love to see your work applied to this area to see what the effects of the number of bicycles using the road. Because I kind of fear, like, I haven't seen anybody on the road. They really put this project in place that seems like a great idea. I wish we could use it. On the other hand, there are other road projects for bicycle routes in Canada that have really been used. I think the tool that you're developing here is would provide a metric for policymakers to be able to say, hey, this works, this is in this area, and maybe we'll other places. But trying to assess the effectiveness of what's part of the place.
Yeah, definitely.
We can get a whole philosophical debate about how that's developed for bicycles. But did you take a look to see if all of those crashes were in the road or if they put cyclists on sidewalks? Very common for cyclists being hit in going across the driveway.
Yeah, so
Not sure.
I was gonna say, we did not look specifically about that. I don't think that was a part of the attribute table. But again, like part of our project is more of just where we would like to implement bicycle lanes based off traffic use, not necessarily bicycle crashes. We just did that as like a visual effect just to like further support the idea of the needing to implement more bicycle lanes around Chapel Hill in particular. I believe time of day was reported in the attribute table with those bicycle crashes. It is not something that we particularly looked at in our project, no. Say that again?
For commuters.
Oh, yeah. Yeah, definitely.
I know that some of the applications that have Strava can be self-tagged to provide there might be a way to do time of day.
Right. Yeah.
I can imagine the gift environment where time of day is doesn't matter.
Yeah.
Yeah.
It's a good idea.
Any other questions? All right. Well, thank you very much.
Thanks a lot, guys.